Right, today we're going to talk about discrete random variables. Standard level, Chapter 7, Section I. So a random variable is a variable that has a value as a possible outcome. So there's two types of random variables. A discrete random variable is a variable that's found from counting data, and I'll give you a few examples. And continuous random data is a variable that's found from measuring data. So let's look at some of the examples I've got here. So number of students in a class. That's something you can count, right? Number of cats in a house. That's something you can count. Number of times you can get heads when you flip a coin. That's something you can count. Continuous data, here's some other examples. So amount of sugar in an apple, the length of a student hair, height of a teacher. These are all things that you measure, not that you count. Okay, so that's an important distinction between continuous random variables and discrete random variables. Okay, so now we're going to talk about discrete probability distribution. So they always use the capital X in our assignment to represent the discrete random variable, and the probability of the variable X is denoted like this. So capital P stands for, we're going to deal with probability, and then the capital X for the variable, and X sub I is the value of the variable. So let's talk about this in an example. Okay, so you're going to flip two coins. What is the probability of getting heads? So when you think about this, you've got two coins. You're either going to get no heads, you're going to get heads once, or you're going to get heads twice. So let's talk about each of these scenarios. So if I don't get heads at all, then I'm going to get tails the first time and tails the second time. So the probability of getting no heads is equal to 1/2 times 1/2, which is equal to 1/4. Okay. Now, the probability of getting heads once, I'm either going to get heads and then tails, or tails and then heads. So this blue path here plus this blue path here, so 1/2 times 1/2 is 1/4, and 1/2 times 1/2 is 1/4. So if I go this route, I have a fourth chance. If I go this route, I have a fourth chance. So the probability of getting heads once is going to be the 1/4 plus 1/4, which is 2/4, or simply 1/2. So I have a half chance of getting one head. Now the third possibility is if I'm going to get heads twice. So if I get heads and then I get heads. So 1/2 times 1/2, that's going to give me 1/4 chance of getting heads twice. Now the important thing to know is these are the probabilities of getting no heads, one head, or two heads. All of these values will never be greater than 1. That's super important to remember. The probabilities are never going to be greater than 1 because all of these have to add up to 1. So 1/4 plus 1/2 plus 1/4 is going to give me 1. All of the probabilities need to add up to 1. Okay, let's do another example. Or let's take some notes first. Okay, so we just said the capital X is going to be the random variable. In the previous example, the random variable was how often are we going to get heads. T subscript I is going to be the probability distribution. So in the previous example, the probability distribution was 1/4, 1/2, and 1/4. Okay, and all of the probabilities added up to 1. Okay, so lowercase x with subscript 1, subscript 2, subscript 3, those are the values of the random variable. So in the previous example, the values of these were 0, 1, and 2. Those were the number of times we were going to get heads. Okay? Hit pause, replay, think about this for a minute. But as you know, as we just said, the sum of all those probabilities has to add up to 1. The sigma symbol stands for sum, and when we add all those, we get to 1. Okay. Let's do another example. Okay, so we go to a magazine store, and in 1 week they sell newspapers to customers. Some customers buy only 1 magazine, some customers buy 2 magazines, some customers buy 3 magazines, some customers buy 4, and some customers buy 5 at this magazine store. Okay, so what is the random variable? The random variable is the number of magazines that are purchased. Okay, so so how many magazines? So the random variable is the number of magazines that we've purchased. You've either purchased 1, 2, 3, 4, or 5. Nobody has bought 1.5 magazines. That would make absolutely no sense. So the random variables are always going to be integers. Okay. Now, what is the probability of each of these? So these are all the probabilities, and all of these have to add up to 1. Okay, so let's look at this question. What is the probability that we're going to get greater than 2? Well, greater than 2 means, oh, wait, oops, yikes. Okay, greater than 2 means these 3, right? 3 is greater than 2, 4 is greater than 2, 5 is greater than 2, right? So we need to add all those together. So the probability of getting greater than 2 is equal to 0.21 plus 0.13 plus 0.5, and we're going to get 0.05. Okay, so 1 and 3 is 4, 9. And 2 and 1 is 3. So we've got 0.39 or a 39% chance that a person's going to buy more than 2 magazines. Okay, now let's look at the next one. What's the probability that the person's going to buy at most 3 magazines? So that means they're either purchasing 1 magazine, 2 magazines, and at most 3 magazines. So we're going to include that. So we're going to have all of these together to get at most 3 magazines. So that's going to be equal to 0.23 plus 0.38 plus 0.21. So this gives us 9, 2, carry the 1. Okay, and then 2, 4, 7, 8. Okay, see if I added that correctly, and there you go. So please do the assignment that is in the handout. Hope this helps. Please let me know if you have any questions.